Okay, so let's practice finding our phase shift. Okay, so for these problems, we are basically going to find the period, the shift left or right, where the wave begins or where the wave ends. Okay, so we're going to find the period and the phase shift, which is basically the true horizontal shift. So there are a couple ways we could do this. So since I see that we have b and h, so I have this in that form of, say, f of x equals sine bx minus h. If we have both of these things, b and h, we have what's called a phase shift. Okay? So finding the period hasn't changed. The equation for period is 2 pi over b. And in this case, my b is 2. So 2 pi over 2, which is pi. So my new period is pi. If my new period is pi, that means I have horizontally compressed my wave. It was 2 pi and now it's only pi long, correct? All right. If my period was horizontally compressed, that means my shift was also horizontally compressed. So that horizontal compression compresses everything. It compresses the period and it compresses the shift. So I know that basically, since this negative sign here, I'm moving to the right. But how far? I'm not actually going to end up moving 3 pi over 2 to the right. Okay, that's before my function was horizontally compressed. So there's an equation that says your phase shift is h over b. Okay, so in this case, h is, 3 pi over 2 divided by b, which is 2. So we're going to take 3 pi over 2 and multiply it by the reciprocal, which is 1/2. So my true horizontal shift is only going to be to the right 3 pi over 4. Okay? So that is how far I'm actually going to shift it. Now, where the wave begins, there's two equations that we can use. Bx minus h equals 0, and where it ends is bx minus h equals 2 pi. These equations here will allow me to find out where the wave starts and where the wave ends. It includes my shift and my phase shift all in one. Okay? Because originally my wave would start at 0 and end at 2 pi. So what this equation does is allows me to see where, with my phase shift and my horizontal stretch of compression, tell me where it starts and where it ends. So in this case, this is going to be 2x minus 3 pi over 2 equals 0. So you move the 3 pi over 2 over, so you get 2x equals 3 pi over 2. Divide both sides by 2, and you get x equals 3 pi over 4. And that's basically what we knew from our phase shift, this number here. But where is it going to end? So again, we do the same thing. We get 2x minus 3 pi over 2 equals 2 pi. So we subtract 3 pi over 2 from both sides. So we get 2x equals, we add it. So we get 2 pi plus 3 pi over 2. And then you get 2x equals, so this is going to be getting common denominators. You get 4 pi over 2 plus 3 pi over 2. So this is 2x equals 7 pi over 2 divided by 2, and you get 7 pi over 4. So that's where it ends, at 7 pi over 4. So that's a way of finding where it begins and where it ends as well. Okay? Using those two equations. It's kind of algebra intensive, but it works. Okay? So we're going to do the same thing for this next one. Okay? So we're going to start with cosine 1/3 x plus 5 pi over 6. So again, we're going to find our period first. So period equals 2 pi over b. In this case, it's 2 pi over 1/3, which ends up being 6 pi. So my period is 6 pi, which means my wave has been stretched by a factor of 3. Okay? My cosine says positive here, so we're actually moving to the left. Okay? But since I have a phase shift going on, we can sit here and we can use the phase shift equation, which is h over b, which is 5 pi over 6 divided by 1/3, which is, yep, same thing as multiplying by 3. So 5 pi over 6 times 3, which ends up being 5 pi over 2. So we're shifting to the left 5 pi over 2. Now, basically, that is our start. That's where our wave begins. So we don't have to do, we know that it's beginning at negative 5 pi over 2 because we're moving to the left. It was at 0. Since we're moving left 5 pi over 2, it's going to start at negative 5 pi over 2. Where is my wave going to end at? Okay. We still use that other equation, so we're going to use b x minus h equals 2 pi. Plugging in what I have, so it's 1/3 x plus 5 pi over 6 equals 2 pi. So it's 1/3 x equals 2 pi minus 5 pi over 6. So 1/3 x equals, so the easiest way, 2 times 6 is 12. 12 minus 5 is 7 pi over 6. So x equals, multiply both sides by 3. So you get 7 pi over 2. So it's going to end at positive 7 pi over 2. So that gives us a good indication where it starts and where it stops. Okay? All right, so using that kind of idea, let's graph this one with its phase shift, cosine with the phase shift. Okay, so let's start by finding our new period. So again, same thing we've been doing. So this is 2 pi over 1/2, which is 4 pi. So our period is 4 pi. Our shift, okay, since it's positive, we're moving to the left. And we have a phase shift going on. So it's going to be h over b, which is pi over 1/2, which equals 2 pi. So we're going to the left 2 pi. Okay, and we have our amplitude, which is now 3. Okay, so just like we've been doing all of our other problems, we start with the cosine parent function. So here's cosine. There's the parent function. So the first thing I'm going to do is I'm going to do my change in period. So I'm going to horizontally expand, stretch. So now my wave starts here, ends at 4 pi. middle at 2 pi, my zeros at pi and 3 pi. So here is my horizontal stretch. We also have our change in amplitude, which means my maximums and minimums get stretched to 3 and to -3. So here we go. There's my change in amplitude. Now, my shift. So I'm shifting to the left 2 pi. So that means my new function is going to start here at 2 pi. It's 4 pi long, so it's going to end at positive 2 pi. And then here, here, and here. So that's my final function. The hardest part about phase shifts is remembering to actually change your shift based on whatever it is that we're doing to the actual period. If we're stretching the period, we're stretching our shift. So originally it looked like we were only going to move pi, but how far did we actually move? 2 pi, because my function was stretched.